Department of General Engineering from Emmanuel J.J. College of Engineering, Natala. I am going to teach the topic two-dimensional random variable. First, I explain the definitions. First, let S be the sample space. Let capital X equal to X of S and Y equal to Y of S be two functions, each assigning a real number to each outcome. Small s belongs to capital S. The capital S is the sample space. The sample space comes from the population. Then the random variable x comma y is a two-dimensional random variable. If the possible values of x comma y are finite or countably infinite, then x comma y is called a two-dimensional random variable. The random variable x comma y takes a particular values. For example, x equal to 0, 1, 2, 3, then we say x comma y is a discrete random variable. Otherwise, x comma y take a period, that is for example 0 to 3 or 0 to 5 or 0 to infinity, then we say the random variable x comma y is continuous random variable. If x comma y can assume all values in a specified region or in the xy plane is called a two-dimensional random variable. Discrete random variable, the joint probability distribution is defined by capital F x comma y of x comma y equal to probability of x comma y, that is capital X less than or equal to small x, capital Y less than or equal to small y. The joint probability function or the joint probability mass function of the discrete random variables x and y, provided the following conditions are satisfied. First condition is the probability is greater than or equal to 0 for all the values of I and j. The second condition is summation j summation I p I j equal to 1. That means the total probability equal to 1. Next, the marginal distribution of x is given by small f of x equal to p capital X of x equal to pi. Similarly, the marginal probability mass function of y is given by f of y equal to pj. The conditional probability of x given y is f of x given y equal to f of x comma y divided by f of y. Similarly, the conditional probability density function of y given x is f of y given x equal to f of x comma y divided by f of x. Only one difference, x given y means in the denominator we are having f of y given x means if the denominator having f of x. Two random variables x and y are said to be independent if pij equal to pi into pj. The product is equal to the probability, then we say the two random variables are independent, otherwise we say dependent. Then continuous random variable, the joint probability density function of the continuous random variable x and y, provided the following conditions are satisfied. For continuous random variable, f of x comma y is always positive. Double integral f of x comma y dx dy equal to 1. Same meaning, the total probability equal to 1. Then the marginal density function of x is f of x equal to integral f of x comma y dy. That is denoted by f of capital X of small x. Similarly, the marginal density function of y is f of y equal to integral f of x comma y dx. That is denoted by f capital Y of y of. That is, the marginal density function of x is the integration with respect to y. Understand the difference. The marginal density function y is integrate with respect to the x. For x, integrate with respect to y. For y, integrate with respect to x. But the limit is same, minus infinity to plus infinity. The integrand also for two formulas f. So, f of x equal to f into dy, f of y equal to f into dx. If x comma y is two-dimensional continuous random variable, then capital F of x comma y is probability of capital X and capital Y is called the cumulative distribution function of x comma y and is defined by capital X comma y equal to double integral small f dx dy. Let x comma y be two-dimensional random variable and capital X the joint probability distribution function, then the joint probability density function is defined by capital F equal to dou square of capital F divided by dou x dou y. Now we are going to the problems. The first problem is in discrete random variable. Given the function is p of x comma y equal to k into 2x plus 3y. X varies from 0 comma 1 comma 2 and y varies from 1 to 3. That is, the x takes the particular values 0, 1 and 2. Similarly, y also takes the particular values 1, 2, 3. So, the given problem is under discrete random variable. The question is find all the marginal conditional probability, also probability distribution function of x plus y and probability function of x plus y greater than 3. In this question, given p of x comma y or f of x comma y, p of x comma y equal to k into 2x plus 3y. X takes 0, 1, 2. Similarly, y takes 1, 2, 3. That is the given question. From this question, we find marginal distribution of x, marginal distribution of y, conditional probability of x given y given x, then probability distribution function of x plus y and probability of x plus y greater than 3. These are the questions. First, the given PDF has one constant k. So, first we eliminate the constant. Eliminate the constant. How to eliminate the constant? We have one property. Total probability equal to 1. Total probability equal to 1. Using that condition, we find the constant value. First you put the tabular column. X value is 0, 1, 2. Y value is 1, 2, 3. Given p of x comma y equal to k into 2x plus 3y. So, for the first cell, listen all of you, x equal to 0, y equal to 1. So, in the PDF, you put x in the place of x 0, in the place of y 1. That is, we replace x by 0 and y by 1. Then we get 2 into 0, 0, plus 3 into 1, 3. So, now we are having one constant, k is in outside, so 3 into k. Similarly, we find all the values in the cell. Second cell, x equal to 1, y equal to 1. Next, x equal to 2, y equal to 1. Second row, x equal to 0, y equal to 2. X equal to 1, y equal to 2. X equal to 2, y equal to 2. Third row, x equal to 0, y equal to 3. X equal to 1, y equal to 3. X equal to 2, y equal to 3. In this way, we can find all the cell values. Then the probability. Just you find the sum of the first row. Sum of the first row. 3k, 5k, 7k. What is the sum? 3 plus 5, 8. 8 plus 7, 15. So, we are having one constant k, so 15k. Similarly, 6k plus 8k plus 10k, that is 24k. Similarly, 9 plus 11 plus 13, 33k. In this way, we find the sum of columns also. Sum of column. First column, 3 plus 6 plus 9, 18. Similarly, 5 plus 8 plus 11, 24. 7 plus 10 plus 13, 30. Then we check the sum of the probability column. Similarly, the sum of the probability row, that should be equal. Otherwise, we put any mistake. Here we are getting 72k. Balancing. Row and column are balanced. That is the total probability. We have the property total probability equal to 1. So we write 72k equal to 1. From this, we find k equal to 1 by 72. Isn't it? Okay. Next, the next question. First, we eliminate the constant. For every questions, we are having constant. First, we eliminate the constant using the condition, the total probability equal to 1. Okay. Next, we are going to the marginal distribution. From the table, directly we write the marginal distribution. What is the first cell? P. First, marginal distribution of x. Okay. What are the values of x? 0, 1, 2. Where x equal to 0? Here x equal to 0. That is equal to x equal to 0. The probability equal to 18k. Directly you write 18k. Next, you replace k by 1 by 72. In the place of k, you write 1 by 72. Isn't it? So, we are getting p of x equal to 0 equal to 18k equal to 18 by 72. Next value 1. So, p of x equal to 1 equal to 24k. 24k equal to 24 into 1 by 72, that is 24 by 72. Similarly, p of x equal to 2. p of x equal to 2 equal to 30k. That is 30 into 1 by 72, that is 30 divided by 72. Similarly, we can write the marginal distribution of y. First, y value is 1. So, p of y equal to 1 equal to 15k. That is 15 into 1 by 72 equal to 15 by 72. Next value, p of y equal to 2. p of y equal to 2 equal to 24k. 24 into 1 by 72 equal to 24 by 72. Next value, p of y equal to 3. p of y equal to 3 equal to 33k. 33k equal to 33 into 1 by 72, that is equal to 33 divided by 72. So, from this table, we can write the marginal distribution of x and y. Okay. Next, we are going to find the conditional probability of x given y. That is also we copy from the table. Okay. First, conditional probability of x given y. So, the x value is 0, 1, 2. So, you write p of x equal to 0 given, write the first value y equal to 1. X equal to 1, y equal to 1. X equal to 2, y equal to 1. Next, y equal to 2. Next, given value y equal to 2. So, x equal to 0, x equal to 1, x equal to 2, given y equal to 2. Next, the x values are 0, 1, 2, given y equal to 3. From the table, you can write. By the definition, p of x given y equal to, already I told, f of x comma y divided by f of y, isn't it? Similarly, p of x comma y, that is p of x equal to 0, y equal to 1. Which cell? X equal to 0, y equal to 1. That is the first cell, 3k. X equal to 0. So, 3k divided by, here I 3k divided by p of y equal to 1. Where p of y equal to 1? 15k. From the table, 3k divided by 15k. 3k divided by 15k. K and k are cancelled. That is equal to 3 by 5. Next, p of x equal to 1, y equal to 1. Which cell correspond to x equal to 1, y equal to 1? 5k. So, 5k divided by 15k. K and k are cancelled. Next, you write it. Directly you write 7 divided by 15. So, just you see the table and write the answer. 3 divided by 15. 5 divided by 15. 7 divided by 15. So, next 6 divided by 24. 8 divided by 24. 10 divided by 24. Next, 9 divided by 33. 11 divided by 33. 13 divided by 33. So, from the table, we can write the marginal and conditional. Similarly, we can write the conditional distribution of y given x. So, you write the value y first, next given y equal to 1, 2, 3, given x equal to 0, 0, 0. Next, y equal to 1, 2, 3, x equal to 1, 1, 1. Next, y equal to 1, 2, 3, x equal to 2, 2, 2. Similarly, you write first y equal to 1, x equal to 0. Y equal to 1, x equal to 0. That is 3 divided by 18. From the table you see 3 divided by 18. Next, 6 divided by 18, 9 divided by 18. Next, 5 divided by 24, 8 divided by 24, 11 divided by 24, 7 divided by 30, 10 divided by 30, 13 divided by 30. Next question is probability distribution of x plus y. We have the values for x and y separately. X equal to 0, 1, 2, y equal to 1, 2, 3. Then we find the sum, that is p of x plus y. First you write 0, 1. 0, 1, the cell value is 3k. So here you write 3k. Next, substitute the value of k, that is 3 by 72. Similarly, for the sum 2, 0 to 1, 1. We have two cells, 0, 1, 1, 1. So 0, 1, 0, 1, 1, 1. Find the sum, that is equal to 6k plus 5k, 11k. So substitute the value 11 by 72. Similarly, next you take the sum 3, 0, 3, 1, 2, 3, 1. These are the possible values for x and y. Here you write x plus y equal to 3. That is 9k, 2, 1, 8k, 7k. 9k, 8k, 7k. That is equal to 24k. That is k. Substitute the value of k, 24 divided by 72. Similarly, x plus y equal to 4. 4 means, here see, 4 means 2, 2, 4. 1, 3, 4. So 1, 3 is 11k, 2, 2 is 10k. That is 21k. That is equal to 21 divided by 72. Next, x plus y equal to 5. X plus y equal to 5, only one possibility, 3, 2. 3, 2. The only one cell, 13k. That is equal to 13 divided by 72. But our question is, probability of x plus y greater than 3. Greater than 3 means 2 possibility, 4 and 5. Greater than 3 means, our question, only 2 possibilities, 4 and 5. So that is equal to p of x plus y equal to 4 plus and p of x plus y equal to 5. That is p of x plus y equal to 4. Here we are having 21 by 72. 5 equal to 13 by 72. If the denominator is same, you add the numerator directly. So that is equal to 34 by 72. These are the answers of the first question. Next question is, given one distribution, then the question is, show that the given probability distribution function is independent. What is the definition of independent? Product of functions equal to the total probability. That is, take 1 by 1 cell. We take the 1 by 1 cell, find out all the cells are satisfying, then we say the given probability is independent. Otherwise, we say the given probability is dependent or not independent. Given here in this question, the x takes the values 2 and 4. Y 1, 3, 5. Y 1, 3, 5. Then we form the table. Y 1, 3, 5, x 2, 4. Then p of y 0.10 plus 0.15. Just you find the sum. First you find the sum row wise. Next you find the sum column wise. Here the total probability always equal from column wise and row wise. Otherwise, mistake. Here row wise 1, column wise also 1. So the total probability equal to 1. Here not given the probability function, here directly given the value. So there is no constant. So we need not to eliminate any constant. Directly we are going to the problem. Okay. Now first take the first cell. The first cell, the corresponding x value is 2, corresponding y value is 1. Okay. So that is P21. That is P21. P21 equal to P of x equal to 2 into P of y equal to 1. P21. Pxy means P of capital X equal to small x into P of capital Y equal to small y. Here capital X equal to 2 given, Y equal to 1. So you write. We have the values from the table you write. P21 equal to 0.10. What is P of X equal to 2? Here P of X equal to 0.40. P of Y equal to 1, P of Y equal to 1 equal to 0.25. So multiply, satisfy. 0.10 equal to 0.10. Similarly, you find for every cell. Similarly, you find for every cell. What is the next cell? P41. What is the value? P41? 0.15. 0.15 equal to, what is P of X equal to 4? 0.6. What is P of O equal to 1? 0.25. Multiplying, we are get 0.15 equal to 0.15. So second cell also satisfied. Next, we are going to the third cell. Third cell, X equal to 2, Y equal to 3. X equal to 2, Y equal to 3. That is 0.20. 0.20 equal to 0.5 into 0.4. That is also 0.20. Next, 4.3. 0.30 equal to 0.6 into 0.5, satisfied. From the table also we can check. Next cell 0.10, 0.1 equal to 0.4 into 0.25, that is equal to 0.1. Next cell 0.15, that is 0.6 into 0.2. So every cell satisfying the condition Pij equal to Pi into Pj. Then we say X and Y are independent. Then I will explain one problem in continuous random variable. First, we have studied two problems in discrete random variable. Now we are going to discuss the problem in continuous random variable. See here. The joint probability density function is f of x comma y equal to 6 by 5 into x plus y square. X takes the values on range 0 to 1. Y also takes the value 0 to 1. So that question comes under continuous random variable. Continuous, that is the difference. If x and y are takes the particular values, then we say discrete. Otherwise, take one range. Then we say that is continuous random variable. Here also we find the marginal functions, marginal PDF. Okay, we say given f of x comma y 655 into x plus y square. X varies from 0 to 1, y varies from 0 to 1. There is no constant, so we can't eliminate the constant. So directly we find the marginal PDF. What is the formula? Already I said the formula. F of x equal to x means integration with respect to y. Y means integration with respect to x. That is the only one difference. Understand? F of x equal to integral f dy. But in our question, the limit for y is 0 to 1. That is, you write 0 to 1. What is f? 6 by 5 into x plus y square dy. So now we integrate with respect to y only. We treat x as constant. So what is the take 6 by 5 is constant, take outside. What is the integration of y? X into y. We treat x as constant, so x into y. What is the integration of y square? Y cube by 3. What is the limit? 0 to 1. We upper limit minus lower limit. Upper limit minus lower limit. The limit for y only. All of you understand? F of x means y. Integrate with respect to y. Also, you apply the limit for y only. That is upper limit 1 minus lower limit. Plus 1 by 3 into upper limit minus lower limit. So, now we see f of x in the variable x only. There is no y variable. All of you understand? F of x equal to the variable x only. There is no y. So, what is the range of x is 0 to 1. So, you write. Similarly, find the marginal PDF of y. Y means integration with respect to x. Same f The limit also same. You write the limit. Integration with respect to x, not y. So integrate with respect to x square by 2, y square into x. Limit. Here also apply the limit for x. Apply the limit for x. So in the place of x, 1 minus 0. Here also 1 minus 0. Then we are, so f of y equal to in the variable y only. F of x equal to in the variable y x only. F of y equal to in the variable y only. Suppose f of x comma y means in two variables x and y only. That is the marginal PDF. One more question we are having. Probability of 1 by 4 less than or equal to y less than or equal to 3 by 4. So now we are going to find probability of 1 by 4. So our integral limit is 1 by 4 to 3 by 4. 1 by 4 to 3 by 4. What variable is here? Y. So you write f of y. dy. F of y means dy. We have the f of y 6 by 5 into 1 by 2 plus y square. The limit also 0 to 1. So you write 6 by 5 into 1 by 2 plus y square into dy. That is 6 by 5 into integration with respect to y. That is 1 by 2y plus y cube by 3. Apply the limit also for y. In the place of y you write 3 by 4 minus 1 by 4. 3 by 4 the whole cube minus 1 by 4 the whole cube. 3 by 4 the whole cube is 27 by 64. 1 by 4 the whole cube is 1 by 64. Then find the calculation. Finally we are getting 37 divided by 5 into 16. That is 0.1. The probability value is always equal to 1. Don't go beyond 1. So the probability in our question, the probability equal to 0.462y. Okay, thank you.